Hello everyone, welcome back to my channel. In this video, we are going to be looking at the characteristics of volcanic landform. A volcano is a mountain or a hill with an opening that connects the Earth's interior to its surface and from which a variety of materials from inside of the Earth is ejected onto the surface. Volcanic landforms can be broadly grouped into two categories: intrusive volcanic landforms and extrusive volcanic landforms. Intrusive volcanic landforms are formed when magma cools inside the Earth's crust. Extrusive volcanic landforms are formed on the surface by the cooling of lava as well as by the accumulation of solid volcanic material. So examples of intrusive volcanic landforms are laccolith, sill, dike, batholith, as well as volcanic plug. A sill is a mass of magma which has solidified along the bedding plane. Laccolith is a mass of magma which has intruded between rock layers so that when it solidifies, it causes the layer of rock above it to arch upwards. So the main difference between the sill and the laccolith is that the sill is a layered structure. It is horizontal in nature. For the laccolith, the feature is arched shape. A dike is a mass of magma which cools across the bedding plane in a vertical or lateral direction. The dike usually forms where magma flows through a joint or a fault and solidifies. A batholith is a large dome-shaped mass of magma which is formed deep inside of the Earth's crust and often acts as a magma chamber. A volcanic plug is a volcanic feature formed when magma hardens within the vent of an active volcano. So while intrusive landforms are created by magma, extrusive landforms are created by materials that are ejected onto the surface. Now, a wide variety of materials may be ejected onto the surface, and these materials may be in a number of states. So it may be gas, it may be liquid, it may be solid, or it may be molten material. Molten material inside of the earth is called magma. Molten material on the surface is called lava. And lava is of two types: basic lava and acidic lava. Basic lava is hotter than acidic lava. Basic lava has a low silica content, while acidic lava has a higher silica content. Basic lava is therefore fluid in nature, while acidic lava is viscous in nature. Because of its fluidity, basic lava is able to flow faster, while acidic lava flows more slowly. Since basic lava is able to flow fast, it can travel over long distances before solidifying. Acidic lava, on the other hand, being of a lower temperature and flowing more slowly, will solidify before it travels over a long distance. So acidic lava usually solidifies closer to the vent. Basic lava is produced from calm or effusive eruptions. Acidic lava is formed from explosive eruptions. The eruptions associated with basic lava occurs more frequently than the eruptions that are associated with acidic lava. Basic lava gives rise to structures that are generally low and gentle and extensive, but there are exceptions. Acidic lava gives rise to steep localized structures. Extrusive landforms may also be the result of solid materials being ejected. Now, some of the solid materials that may be ejected from a volcano include ash, cinder, bomb, block. Ash is the finest solid material ejected from the volcano. It can be very dangerous and hazardous because it is light and it might be suspended in the atmosphere for a very long time. It also has sharp edges and can do a lot of damage. In fact, most of the solid component of the ejected materials are actually ash. Cinders or lapilli are pebble-shaped volcanic materials. Bombs are larger materials with aerodynamic shapes. Blocks are the largest solid volcanic materials and may even be materials that have broken off the cone as eruption takes place. Now, an example of an extrusive volcanic landform is a lava plateau. Lava plateau is formed from basic lava. Now remember that basic lava erupts frequently, is fluid in nature, and can flow over a long distance. Now, oftentimes, as we can see in this diagram, lava plateau forms where the lava is ejected from a vent or a long crack in the earth. A good example is Iceland, where there is a divergent plate margin where the plates are moving away from each other and creates a fissure. Now, material will rise through that fissure, and because it is fluid in nature, it will flow over a long distance. And in the initial stage, if there is any depression or valley, the material will flow and fill in those spaces, those gaps, so that a generally flat area is created in the process. And because of the frequency of the eruption, new layers of lava will be built on top of the previous layer of lava. And so over time, a highland with a flat top will be created. A shield volcano is also associated with basic lava. It is formed where basic lava is ejected from a central vent and flows over long distances to create a cone that is low and has gentle sides. This type of volcano is often found over hotspots. Example, in the Hawaiian Islands. Acid lava dome is a high dome-shaped volcanic cone with a narrow base and steep convex slopes. It is the result of the eruption of acidic lava. Because the lava is viscous in nature and the temperature is not as high as the basic lava, the lava will solidify closer to the vent. So it is unable to flow over a long distance. And this is what gives the cone its dome shape or its convex slopes. And this is why it is generally high and steep. Now, a composite cone, also called a strata volcano, is a large and steep cone with alternating layers of lava and ash. So, in one eruption period, the volcano may eject lava, and in the following eruption period, the material ejected may be ash. And so, as this continues, the structure that is created will consist of alternating layers of ash and lava. Now, the lava associated with this cone, of course, is acidic in nature. And so sometimes the vent or the pipe may become plugged, and so the material may take another route. And so secondary pipes may be created, and as material flows through these secondary pipes, they may give rise to secondary cones built along the slopes of the cone. Now we're on to ash and cinder cone. An ash and cinder cone is a volcanic cone with concave slopes formed from the accumulation of pyroclastic materials, including cinder and ash. Now, the lighter materials will be blown further away from the vent, while the heavier materials will accumulate around the vent. And this is what gives the cone its shape where the slopes are concave, meaning that it is steeper at the top and gentler at the bottom. This cone is generally a small cone, though it is a steep cone. A caldera is a large basin-shaped depression formed when the top of an existing cone has collapsed. After the summit or the top of the volcano has been removed by the explosive eruption, eruption may continue. And because the eruption is continuing, then this might cause secondary cones to actually form inside of the widened crater. Also, sometimes the enlarged crater is filled with water, and therefore a crater lake is created. Now, over time, volcanic landforms may change. For example, volcanic eruptions may result in volcanic structures, existing volcanic structures increasing in size. On the other hand, violent eruptions may cause a volcano, the top of a volcano, to be blown off, and this will create calderas. Now, the level of activity of volcanoes may also change over time. So, an active volcano, a volcano that was previously active and erupting relatively frequently, may become dormant with time or may even become extinct. So, a dormant volcano is a volcano which has not erupted for a long time but still has the ability to erupt. Extinct volcano, on the other hand, is a volcano which has erupted in the past but has completely stopped erupting. Another change that may take place with volcanic landforms is that the volcanoes, particularly those that are extinct, may become subjected to different processes of denudation, such as erosion or weathering or mass wasting. And this may cause the intrusive landforms created inside of the earth to be exposed on the surface. Sometimes groundwater may come in contact with hot magma, causing the groundwater to be heated up so that when it is ejected onto the surface, it may be ejected as hot springs. Okay, so this is where I will stop. Thank you for watching. Please don't forget to like, to share, and to subscribe.